All right, today we are jumping into one of the most famous and, frankly, most readable papers in the history of psychology. It's a classic from 1956 that uncovered a very strange and very specific limit on how our minds work. I mean, what an opening line, right? You'd think this is from some kind of mystery novel. But nope, it's the first sentence of a scientific paper. The author, George Miller, literally says he's being haunted by a number. He says it's been following him around for years, just popping up over and over again in his data, no matter what he studies. And that number, it was 7. So, let's treat this like a detective story. What's the deal with the number 7? Is it just some fluke, a random coincidence, or does it point to a fundamental boundary on our ability to process the world? Let's follow the evidence, just like Miller did. Okay, our investigation kicks off in the world of perception. The first place this mysterious number shows its face is in a concept that psychologists call absolute judgment. So what exactly is absolute judgment? Well, it's when you identify something all on its own, without comparing it to anything else. The classic example is a musician with perfect pitch who hears a note and just knows, that's a C sharp. Miller wanted to figure out where the limit is on that ability. What's our channel capacity? How much information can we actually handle this way before it all becomes a blur? So here we have our first clue. This is from an experiment with musical notes. As you give people more and more notes to choose from, the amount of information they can actually process correctly just levels off. See how that line flattens out? That plateau is key. It basically maxes out at our ability to reliably identify about 6 different pitches. After that, we start getting confused. Okay, so maybe that's just a weird thing with sound, right? A fluke? Well, let's look at loudness. This graph shows a strikingly similar pattern. Our ability to judge how loud a sound is, in absolute terms, hits a ceiling at around 2.3 bits. Now, that translates to only about 5 different levels of loudness we can consistently tell apart. The pattern is definitely holding.
Let's switch senses entirely. How about taste? In this experiment, people had to judge the saltiness of different solutions. And what do you know? We see the exact same kind of limit. The channel capacity here is even lower, around 1.9 bits, which means we can really only distinguish about 4 different levels of saltiness before we start making mistakes.
And for our final piece of evidence in this part of the investigation, let's turn to our eyes. How well can people judge the position of a little dot on a line? This one's our highest number yet, coming in at 3.25 bits. But even that only translates to about 9 or 10 distinct positions we can reliably identify.
So, here's the crucial point. It doesn't seem to matter whether it's hearing, tasting, or seeing. A really clear pattern emerges. Our channel capacity for these simple, one-dimensional judgments always seems to fall into this incredibly narrow range, 7 plus or minus 2. Miller's persecuting number has officially entered the building.
But wait, the plot thickens. The story doesn't stop there. Miller started to wonder if this limit on our judgment was somehow connected to another famous mental bottleneck, our memory.
And this is the million-dollar question. If our brain has a fixed capacity for processing information, which is what all those judgment experiments seem to suggest, then shouldn't our short-term memory work the same way? It sounds logical, doesn't it?
This graph shows exactly what you'd expect to see if that were true. That dotted line is the constant information theory. Think of your brain like a bucket. If the bucket can only hold so much information, then you should be able to remember a ton of really simple items like binary digits, but only a few really complex items like random words. The more info-packed each item is, the fewer of them you should be able to fit in the bucket. Simple.
But now look at the solid line. That's what the real data says. And this is where our mystery takes a massive twist. That theory, it is completely, totally wrong. In reality, our memory span for binary digits is about 9. For regular numbers, it's about 7. For random words, it's about 5. It barely changes. It turns out we don't have a memory for a fixed amount of information. We have a memory for a fixed number of items. And boom, this is the giant aha moment of the whole paper. We are dealing with 2 completely different kinds of mental limits. Our absolute judgment is limited by the number of bits of information. But our immediate memory? That's limited by the number of slots, or items. And Miller gave those slots a name that stuck. He called them chunks.
Okay, so if we only have about 7 chunks, or slots, in our short-term memory, how in the world do we remember all the complex stuff we do? Well, that brings us to the final act of our investigation, a powerful mental trick Miller called recoding.
Recoding is the secret. You probably know it by its more famous name, chunking. It's how we break through that bottleneck.
Miller uses this great example of a telegraph operator learning Morse code. At first, every single dit and dah is a separate chunk they have to process. But with practice, they stop hearing the dits and dahs, and they start hearing letters, then whole words. They're recoding all that input into fewer but way more meaningful chunks.
Let's make this super concrete. An 18-digit string of ones and zeros is pretty much impossible to remember, right? But check out this table. You can recode it. If you group the digits into little clusters of 3, like 101, you can give that group a new name, the number 5. Suddenly, that impossible string of 18 items becomes a totally manageable string of just 6 items. You've packaged the same information into bigger, smarter chunks.
And you might be wondering, does this actually work? Oh boy, does it ever. This graph is just incredible. It shows the results for one person who sat down and actually practiced these recoding schemes. By mastering this art of chunking, he was able to take his memory span from about 9 binary digits all the way up to, get this, 40. He could hear a string of 40 ones and zeros and repeat it back perfectly. That's the power of recoding.
And listen, this isn't just some weird lab trick. You do this constantly without even thinking about it. A phone number isn't 10 random digits. It's 3 chunks: area code, prefix, and the last 4. An acronym like NASA packs a whole phrase into a single, easy-to-remember chunk. Miller even argued that when you try to remember an idea by putting it in your own words, you're actually chunking it. You're packaging a big, messy concept into a single chunk that makes sense to you.
So, after following all the evidence, we've arrived at the end of our case. What's the final verdict on the mysterious number 7?
The case really comes down to this. Our minds seem to have 2 major bottlenecks, and strangely, both of them hover right around the number 7. First, our ability to make absolute judgments is limited to about 7 categories. Second, our immediate memory is limited to about 7 chunks. But the secret weapon, the way we hack that memory limit, is recoding. It allows us to pack more and more information into each of our 7 precious slots.
But what did Miller himself think in the end? Was there really something magical about the number 7? After laying out all this evidence, he kind of takes a step back. He lists all the famous 7s, the 7 wonders of the world, the 7 deadly sins, and basically concludes that the number 7 showing up in his own research is probably just a pernicious Pythagorean coincidence.
But here's the thing. Coincidence or not, Miller's investigation uncovered a fundamental truth about how we learn and remember. The number of slots in our short-term memory might be fixed, but our ability to build bigger, better, and smarter chunks to put in those slots, well, that's limitless. And that leaves us with one last question for you. What are the informational bottlenecks in your life, and how can you use chunking to smash right through them?